In this video for section 9.2, we're going to talk about how to test a hypothesis about a proportion. The basic concepts are the same as doing tests for means. One of the main differences is that when we write the null and alternative hypothesis, we use p for proportion instead of mu. So let's look at this example. We have a basketball team that's considering raising their ticket prices, but the marketing manager does not want to implement the price increase if more than 10% of the season ticket orders would be canceled. A random sample of 100 ticket holders found that 14 would cancel their orders if the price change were implemented. Is it possible to conclude at the 0.05 level of significance that more than 10% of the season ticket orders would be canceled? So our claim here is that more than 10% of the orders would be canceled. And our random sample of 100 ticket holders found that 14 would be canceled. Now 14 would be 14%, 14 out of 100, but we want to know if that is significantly enough above 10% that we could say that more than 10% of the orders would be canceled. And we're doing this at the 0.05 level of significance. So that's going to be our alpha. So let's start with our claim here. Our claim is that more than 10% would be canceled. So let's write our null and alternative hypotheses. As usual, I'm going to start with the alternative. So my alternative hypothesis is going to be that P is greater than 10%. And when we write these with proportions, we're going to want to convert percentages to decimals. So 10% I'm going to write as 0.10. My null hypothesis is the opposite of that, so it's that P is less than or equal to 0.10. So when I'm entering this in Minitab, I'm going to have my number of events and my number of trials. And that's going to be the 14 out of 100. So let's take a look at what this looks like here. I'm going to go to Stat, Basic Statistics, and then down to 1 proportion. And then I'm going to change this drop down to Summarize Data. So number of events is going to be the 14 out of the 100 total people that were surveyed. Number of events is always the smaller number, smaller than the number of trials. If you put these in backwards, you're going to get an error message. And then we're performing a hypothesis test, so I check the box. My hypothesized proportion is the 10%. Remember, hypothesized proportion comes from your hypothesis. My alternative hypothesis is that P is greater than 0.10. So that's what I put in for that. Now I'm going to click on Options. Again, confidence level, I can leave that alone since I'm not doing a confidence interval, but I need to change my alternative hypothesis to match my hypothesis that I wrote. And so my alternative hypothesis is that proportion is greater than 0.10, so proportion greater than hypothesized proportion. Now, something that you have to do with these proportion problems is change the method from exact to normal approximation. Now, it sounds like you would want to keep it on exact because that would, well, be more exact. But in order to get problems correct in MyLab, we're going to need to use the normal approximation method. So change that method, click OK, and then click OK again from this box. It's going to ask you to save, and then you will get your results. So it tells me that normal approximation method is used. It's giving me my statistics here, my 14 out of 100, and then I have my test results. So again, I have z-value and p-value. Z-value of 1.33. If I need to put that in for the problem, I can do that. And my p-value is what I use to determine if I am rejecting or failing to reject the null hypothesis. So p-value is 0.091. So let me write that down. So remember, I'm comparing the p-value to my alpha. So my alpha is 0.05. So since my p-value is not less than alpha, p-value is greater than alpha, that means that I cannot reject the null hypothesis. So since 0.091 is greater than 0.05, I fail to reject H0. If my alpha here was 0.1 or 10%, then I could reject the null hypothesis because my p-value is less than 0.10. But since I'm using an alpha of 0.05, my p-value is not less than that, and so I fail to reject the null hypothesis. So what does that mean about my situation? Well, I do not have evidence that more than 10% of orders will be canceled. So I do not have evidence to support the claim.